Okay, so let's look at some examples. All right, so we need to complete the chart, and we also need to graph a rough sketch of our polynomial. So the first thing I'm going to do is say, is it in standard form? So do I have this in standard form? No, because it goes from x squared to x third to the third. So I'm going to rewrite this in proper form. So I'm going to say negative x to the third plus 3x squared. Okay, now this puts it in the right order for me, and I know this is my leading coefficient, or sorry, my leading term. And so I know that to classify this, if it's x to the third, that is a cubic polynomial or cubic function. And because it has two terms, it's going to be binomial. Okay, and this comes from the chart above on the left. Okay, the degree that we have here, this is to the third degree, and my leading coefficient is -1. Now, these are important because they're going to tell me my end behavior. So as x approaches positive infinity, so as my graph goes to the right, remember, the leading coefficient is going to tell me if it is heading in the positive direction or the negative direction. And since my leading coefficient is negative, that tells me I'm heading in the down toward the negative direction. I'm going to change colors so we can see our graph. Okay. And so that tells me that because it's negative, y is approaching negative infinity. Okay. Now, negative infinity, what's it doing on toward the left? If I go toward negative infinity, that comes from the degree, and the degree is 3, and it's odd. So that tells me it's going to go in the opposite direction. So as x approaches negative infinity, y is going to approach positive infinity. Okay, now we need to graph this so we can find our relative min and relative max and our zeros. You do have a couple options. You can factor this, and there will be a couple problems where I ask you to factor. Or if it doesn't say to factor, you can hop over to your Desmos calculator and graph it and find the zeros there. So we'll go to Desmos, and you can see that I already have this graph in here, this 3x squared minus x cubed. And we are looking for the relative min and the relative max. So you can see here, I have a minimum. And remember, if I click on it, it will highlight that point for me. So I have a relative min at 0, 0. So let's go back over here and say my relative min. I have one of them at 0, 0. What that means is on my graph, I'm going to plot 0, 0. But since it's a minimum, that means it's the low end of a dip. So I'm just going to put a little dip right there. That just tells me visually that it's a minimum. And then I have a maximum, a relative max over here at 2, 4. So we'll go back over and we'll show that we have a relative max at 2, 4. I can go to my graph and I can plot that point, and I can also just put a little cup there reminding me this is a maximum. Okay, and then I want to find my zeros. Well, 1, 0 I already have at 0, 0. Whoops. And the other one is over here at 3, 0. So I have 2 zeros. Remember, my zeros are where they cross the x-axis. Okay, so here we have this one already plotted, and then 1, 2, 3, we know that we have to go through this point as well. Okay, and we've already determined that it's going to go up and to the left, and so we know the graph is going to go this direction. And we know it has to go down and to the right. So it's going to come from here and kind of go down that way. And then all we have to do is just fill in this missing gap of what's in between is to connect those. And you can see that it kind of does look like that on our Desmos graph. So this is a rough sketch. This is not like the graphs before where you had to pick 4 or 5 points and plot them. Here, what we're looking for are the relative min, relative max, the zeros, and then end behavior. Okay, let's try another one. So this one we need to classify as well. So it is x to the 4th. So this is a quartic function, and it has 1, 2, 3, 4 terms, so it's a quartic polynomial. Okay. My highest degree, now 4, 3, 2, 1. So this is my leading term. So my highest degree is 4. My leading coefficient, there's no number out front. So remember, that's going to be a positive 1. So now let's look at our end behavior. Okay. My leading coefficient is positive. So that tells me it's going to head to the infinity. It's going to go up and to the right. And my degree is even, so that tells me that to the negative infinity is going to go the same direction, also up toward positive infinity, so up and to the left. Okay, then we can go to Desmos and we can find our max, min, and zeros. And again, if you want to factor, go right ahead and factor this. So we'll start with the maximums and the minimums first. So if I click on this, you can see it gives me a negative 1.838 and a negative 6.3. So we're going to go ahead and just round to the nearest tenth because our graph is not that specific. Again, we're just looking for a sketch. So a minimum is negative 1.8 and a negative 6.3. Okay, so if I go here to negative 1.8 and then 1, 2, 3, 4, 5, 6, we'd have to estimate it would be about down here, and this is going to be a minimum. Okay, and then notice right here in the middle of my graph, I have a relative maximum. So that's going to be 0, 2. So we can put our maximum in here, 0, 2. And it's a max, so we're going to show the graph has to curve downward on both sides. And then we have another relative minimum notice I have a couple different dots here. So let's zoom in and see what is going on right here. Aha. As we get closer, we can see we actually have a couple x-intercepts here, and my minimum is actually down here. So we're going to say it's at 1.1 and negative 0.05. Okay, so that's another relative minimum, 1.1, negative 0.05, which is just slightly below the x-axis. So we'll go a little past, a little under, and this is going to be a minimum again. So it has to go above. And now we're looking for the zeros. Okay, so I'm going to hit the home button. And I have a 0 here, which is about negative 2.5. 0. So we'll go over here. And I know I have to go through the graph there. And we have a 0 at negative 0.7. Which is not quite 3/4 of the way, so we'll put a point right there. And then I have these two that I have to zoom into to look at. So one of them crosses at 1, so we can go ahead and put that one in there. And we're going to cross at 1. That is very small on our estimate. And then we cross at 1.2, which is also going to be very small. Okay, remember, according to our end behavior, we know that it's going to go up in both directions. So when we curve up here, we need to make sure that we go through this point. Okay, and we can connect right here because we already know where it crosses the graph. This one, we need to make sure when we connect these, we go through this 0 and connect it with this, and our graph should look very close to the graph that we get in Desmos. Okay, go ahead and try the check your understanding.